quadrilateral ABCD has coordinates at 3, 2, 1, 6, 5, 8, and 7, 4. Graph it, and then what shape is it? Justify your answers. So let's go ahead and plot those points. So we've got our first point was at 3, 2. We've got a point at 1, 6. We have a point at 5, 8, and 7, 4. And if I draw this, certainly looks like it could be a square. My big question is, how do I know it really is a square? Well, that has a lot to do with the slope triangles. And if I go around, all of these are 2 by 3. So this is a square. It has 4 congruent sides. Now, I haven't even said what the side lengths are, but I just say this. I know that they're congruent because they're all bounded by right triangles that are 2 by 3. 2 squared is 4, 3 squared is 9. Each one of those are the square root of 13 units long, and that's a decimal if I care. And I have 4 right angles, and I have right angles because the slopes are opposite reciprocals. So in one case, it's down 3 over 2, right? Down 3 over 2. And then for the other one, it's up 2 over 3, and that's a positive slope. So they are opposite and reciprocals. So because of that, because I have opposite reciprocal sides, I know that it has to be a rectangle. And then it says, I'm going to apply this rule that xy, what does it say? It says, yeah. Okay, so now it says this thing is rotated 180 degrees about the origin to produce a new one. Then it is reflected across the x-axis to form this double prime one. Name the coordinates of point C and name the coordinates of point C prime. That's after the first reflection, and then D double prime. So if I come back to this, this is what I get when I go 180 degrees around. And in fact, I know that the rule xy gets mapped to the opposite of x, the opposite of y. That's a rule for 180 degree rotation. So here's my shape after it's gotten transferred down there. Now, see, I didn't label the coordinates of the original shape, but C was at 5, 8. And C double prime, or C prime rather, is going to be located at -5, comma, -8. So for C prime, x is at -5, -8. Then the other thing that happens then is it says I have to now reflect this across the x-axis to figure out where D double prime is going to go. So I'm not going to do all of those shapes, but if I look at where D, if I look at this, you can see these green dots here. These green dots are the reflected points. So I'm reflecting across the x-axis. And the one spot where D is going, you can see here's where D is, right? D is going to go up to here. So this is D double prime, and D double prime is located at -7, 4. So we've got D double prime is located at -7, 4. And C, I'll write down the rest of these. So C prime was at -5, -8. D double prime is at -7, 4. And then finally, the perimeter of that is 4 times the square root of 13. It expressed as a decimal, it's about 14.2 units. And the area is 4 times root 13 times 4 times root 13. Well, 4 times 4 is 16. Oh, no, I'm sorry. It's root 13 times root 13. When you multiply the square root of 13 times the square root of 13, you just get 13. So the area of that is 13 square units.